Dear student, myself Rajendra Aaseri, I am assistant professor in computer science department at Government Bangalore PG College, Didwana. So in the previous lecture, we have started a new concept called SSL or TLS security. Means how to ensure the security at transport layer. Different versions are used like SSL and TLS. So in the previous lecture, we have discussed various type of web security consideration, why the security is required at application layer, why it is required at transport layer, various aspect of the security consideration we have discussed in the previous lecture. Then we have discussed already about the protocol stack of the SSL. Various protocols are there, various fields are there, like SSL handshake protocol are there, SSL record protocol are there, SSL alert protocol are there. Clear? So all these concepts already discussed. Today, in today's lecture, we will discuss in more detail about these concepts. So in this lecture series, as the outline, web security consideration we have already discussed. SSL and TLS abstract concept or abstract overview already given, and next is SET, which we will discuss in the next lecture. So in today's lecture, we will be focusing in detail about SSL and TLS. So first, SSL record protocol operation. Clear? So SSL record protocol is basically a part of the SSL protocol stack, right? Second point, at the application data, when we are sending the application data, it is in the form of message. A single message is there, content is in the form of a single unit. Clear? So at first step, single unit is there. Clear? So at first step we need to make the fragment, different block or fragment we need to divide. So application data will be divided into different same size of fragment, or it can be of variable size fragment also. After that, every fragment, since the fragment size is very large, so we need to minimize the size. So how to minimize the size of any content? With help of compression. So we need to compress. What we need to do? After that, we need to compress. While compressing, our fragment size will be reduced at least by 33%. By 33% it will be reduced. Okay. Next, after that we need to add the MAC address. MAC stand for the machine addressable code. Clear? So it is address which we can say it is MAC address is basically a physical address. Every machine is having a different or unique MAC address. It is a given by the manufacturers. Clear? So we need to add the machine addressable code or MAC address. So here we have added with the compressed content, MAC address has been added. After that we need to ensure the security of this content, so we need to encrypt this. So this is the encrypted message content with the embedded with the MAC. After that we need to append SSL record header. So header will be added at the starting. So again I am summarizing. Initially we are having application data. We have divided in a same size data, same size block, that called as fragment. After that, to reduce the size of the fragment, we just compressed the fragment, the compressed fragment. After that we have added MAC address to this compressed format. After that, this compressed format with the embedded MAC is encrypted with some cryptographic algorithm, and at the end we need to add SSL record header to this particular content. Clear? Encrypted format. So this is the final content, or as these all operations will be done by the SSL record protocol stack, right? Now next is SSL record format. So in SSL record format, there are various type of field. First is responsible for the type of the content. First is type of the content. Second, indicate the version of the protocol, major version. Third is minor version, like 4.3.1.1. So major version is the prefix part, and minor version is the we can say suffix part, right? Then compressed length. After the compression, how many bytes the data is in the form of bytes, so how many bytes are there? The compressed length we need to write down here in the form of numeric. After that, plain text, it is optionally it is a compressed format. Clear. In encrypted, we need to add the MAC address. MAC address is either 0 byte, 16 byte or 20 byte. So in this manner, SSL record format can be arranged. Clear. Now SSL record protocol payload. So suppose we are having SSL in SSL record protocol payload, we are having change cipher specification protocol. It is of 1 byte. Clear. Second is alert protocol. Alert protocol is having a two field. One is level of 1 byte and alert is of again 1 byte. Clear. Third is handshake protocol. In handshake protocol there are three field. First field is type, second field is length, and third field is content. So type is of 1 byte, length is of 3 byte, and content is of 0 byte. Fourth is other upper layer protocol like HTTP. So HTTP is contain all the opaque content of 1 byte. Clear. Again, I'm summarizing. So every protocol is having a different format with the different size. First, change cipher specification protocol is of 1 byte and only one single block is there. Second, alert protocol is of 2 byte having two block. One block is called as level and second block is called as alert, and both the blocks are of 1 byte. Third is handshake protocol. In handshake protocol there are three field. First field is called as byte and it is of 1 byte. Second field is called as length and it is of 3 byte. Clear. And third field is called as content which is of 0 byte. Clear. Next is other upper layer protocol like HTTP. In HTTP 1 byte opaque content is there. Now comes the handshake protocol, right? Now, as the name implies, handshaking means three-way handshaking where we need to apply source to destination, destination to source, and again source to destination. Clear? So in handshake protocol, it is the most complex part of the secure socket layer protocol stack. Clear? Why? See, it allows the server and client to authenticate each other. Suppose client and it is the server. So client will authenticate server, server will authenticate client, and at the end client will ensure the acknowledgement. So it is basically applied three-way handshaking. First client will ensure the server, server will authenticate the client, and then client will send the acknowledgement of the acknowledgement to the server. Third step. Clear. That's why it is called as very complex part of the SSL, because the steps involved are very complex, right? Next is it will negotiate encryption, MAC algorithm, and cryptographic keys used before any application data are transmitted. It is basically used before any application data are transmitted. Now transport layer security. So at transport layer, the same record format as the SSL record format. Transport layer security. So TLS is having a same record format as the SSL record format. No change are there. It is basically defined in RFC 2246, request for comment. Uh, for every content there is a Wikipedia page. Similarly, for every protocol, from where the protocol has been initiated, what are the various application of that particular protocol, what are the various improvement in the, we can say, in the protocol formation for so all these step by step process are written in RFC, and every protocol is having a different RFC, request for comment. It is similar to SSL version 3 TLS. Now there are some differences like in the SSL and TLS, like version number. SSL version number and TLS version number both are different. MAC, message authentication code, for SSL and for the TLS are different. Third, pseudo random function. Pseudo random function is also different for SSL and TLS. Alert code different for TLS as well as SSL. Cipher suite also different for the SSL and TLS, right? Next is client certificate type. So for the client, there are different certificates are there. So both all the type of certificate are different for TLS as well as SSL. Next is certificate verify and finished message, different for both TLS and SSL. Cryptographic computation, different. Padding is also different for the SSL and TLS. So in this manner we can say that SSL and TLS are similar, having some we can say some differences. Some exceptions are there, like version number is different, message authentication code is different, pseudo random function is different, alert codes are different, cipher suits are different, client certificate types are different, certificate verify and finished messages are different, cryptographic computation are different for SSL and TLS, and padding, number of bits used in padding for SSL are different from number of bits used in padding for the TLS. So TLS and SSL are having different padding bits. Clear? So in this lecture, again I am summarizing. We have started with the SSL protocol stack. In SSL protocol stack, there are various sub protocol, like SSL record protocol is there, SSL handshake protocol is there, SSL alert protocol is there, SSL change cipher specification protocol is there. Clear? So in SSL record protocol protocol operation, step by step we need to change add the header. So first we need to divide our application data into various fragments of same size or different variable size. After that we need to just compress to reduce the size of the fragment. Then after that MAC address will be added to every compressed fragment. Then the encryption process will be applied to ensure the security of the fragment. Then we will append the SSL record header. Clear? So in this manner SSL record protocol operation will be done. Now SSL record format is having different field, like content type, major version, minor version, compressed content length. Clear? And it is having encrypted format content. First is plain text, which is optionally in the compressed format, and second is MAC, which is of 0 byte or 16 byte or 20 byte. SSL record protocol payload, and length of the payload or data of every protocol is different. Change cipher specific protocol 1 byte length, alert protocol 2 byte length. One is for label field, second is for alert field, third is handshake protocol. It is having three component. First component is type, which is of having payload 1 byte. Second is of 3 byte length, and the name of the field is length. Clear? And third is the content basically optional, or it is of 0 byte. Now handshake protocol is responsible for the three-way communication between client and server. First client will send the authenticate the server, then server will authenticate the client, and client will again send the acknowledgement of the acknowledgement received from the server. Clear? So in this manner handshake protocol will be used in SSL record protocol stack. After that HTTP, it is basically very common protocol, and it is used at the application layer side, right? And it is having only the opaque content of 1 byte. A handshake protocol, the most complex part of the SSL, we all know why, because it allows three-way handshaking. Three steps are allowed before the communication from the server, and client will authenticate to server, server will authenticate to client. So both server and client will authenticate each other. It negotiates encryption, MAC algorithm, and cryptographic keys. It is used before any application data are transmitted. Then we have discussed the differences between SSL and TLS. So all these differences we have already discussed. Clear? In the upcoming lecture, we will be focusing on a very important topic called as SET, Secure Electronic Transaction. So that's all from this particular lecture. Thank you.